Today you will learn how Simility implements real-time detection of fraudulent behavior and their use of Redis Labs to maximize scale and availability. You will also gain insight into real-time fraud detection, architecture, and best practices with Redis, along with how Redis Labs maximizes scale and availability in Simility's high-volume fraud analytics systems. Our presenters today are Leena Joshi, Vice President of Product Marketing at Redis Labs, and Ravi Sandupi, Head of Engineering at Simility. Today's broadcast is being recorded. Following today's event, an email with a link to the recording will be sent to you for sharing with your fellow workmates. We will be taking questions throughout the broadcast. There is a question and answer feature in the control panel that you will use to post questions. Questions will be answered in the order that they are received. We want to thank you again for joining us today, and at this time I'll turn the broadcast over to Leena. Hey Leena, take it away.
Thank you, Sharon. Welcome everybody to this webinar. Our agenda today is going to be a very short introduction to the Simility Platform, a short introduction to Redis and Redis Labs, a deep dive into how Simility implements their real-time fraud detection architecture, and how they're using Redis Labs. My co-presenter today is Ravi Sandupi, VP of Engineering at Simility, and I will ask him to do the quick introduction to the Simility Platform.
Thanks, Leena. Hi, everyone. I'm Ravi from Simility. So what's Simility? Simility is a fraud detection platform. Our differentiator is that we try to combine the best of human analysis along with very deep machine learning. We strongly believe that a combination of both really helps us stand out in terms of identifying and adapting to new kinds of fraud very quickly. We have a very broad spectrum of customers that include banks, payment processors, e-commerce companies, classified social networks, telecom, and so on. And these companies are spread across North America, South America, Europe, Africa, and Asia. Antarctica is probably the only one that's left for us, but kidding aside, we have a global distribution of customers. Next slide, please. These are some of our customers. On the left-hand side, you'll see some of our e-commerce and social networking websites. These are some of the top players in their respective markets. For example, Semhora is a big ticketing website in South America. TravelStart is one of the fastest growing travel websites in the Africa region. Big Basket is the biggest e-commerce website in India. And on the right-hand side, we have a bunch of financial institutions. Chime Card used to be called OneDebit previously, Zions Bank, TMG, which is a payment processor, and then Moneto, which is again a payment processor in the South America region. These are some of the examples of customers who work with us. Next slide, please. So what is the Simility platform? We have three broad components of our platform. The first and most important component is our API, which is driven by our rule and AI engine. So this rule and AI engine is the main part that computes the fraud probability score for every transaction that we receive. Behind the scenes, a bunch of machine learning algorithms that we've built from scratch, along with a bunch of proprietary rules that our analyst team figured out through the 2 years that we have been functional in. And have handwritten these rules specific to each vertical and each geography. So all of these run on every transaction that we receive, and we respond back with a fraud probability score. Our customers use that score in whatever way that's appropriate to them. That could be either declining the transaction, approving the transaction, taking down a user account in case there are social networks. If they're classifieds, it could be flagging chat messages, comments, flagging photo uploads, and so on. Next slide, please. The second big part of our product suite is a UI that we call Workbench. So this UI runs on top of all the transaction data that we have received so far from our customers. There are three big parts in the UI. The first one is a dashboarding system where our customers can write their own custom dashboards. They can track, they can write alerts on various things that they want to track. The second part is a review UI where they can manually review and take actions on transactions or other entities that are suspicious. So these are entities which we are not sure of whether they're good or bad. So in these cases, like humans go and review those entities. The biggest advantage of using our platform is we express all the transactions as part of a huge graph. So every entity is interlinked. So for example, if someone finds an IP address as suspicious, they can quickly open it up in our UI. They can find all the related email addresses of that IP address very quickly, and from the email addresses they can find all the related phone numbers and so on, and they can keep expanding the graph and take an action on the complete cluster at once. And as soon as they take an action, all this feeds into training our machine learning models that will improve identifying such behavior in the future. The third part is we have rule and review workflow management system where our customers can write their own custom rules. These are generally business logic that define violations of terms and conditions and so on. They need not be truly fraud per se, but it could be violations of their agreements or terms and conditions. And they can also build custom queues for their analyst teams to review. So for example, they can split their transactions across geographies, or if they have different products, they can split their queues across multiple products and so on. Next slide, please. And the third component of our product suite is our device recon product, which is a device fingerprinting solution. So these are client-side libraries. For browsers, it's a JavaScript library. For Android and iOS devices, these are respective SDKs in those platforms. So what these libraries do is so our customers use these libraries within their web apps or their mobile apps. And these libraries, what they do is they collect a bunch of hardware information about the device on which their apps are running. We use various aspects of this hardware information to generate a unique device fingerprint. We try to generate this fingerprint in a way such that even if the person is changing certain aspects of the device, like changing this monitor or clearing cookies or changing the browser and so on, we still generate the same device fingerprint. This really helps us because fraudsters generally create thousands of accounts very easily, but they have limited access to unique devices, hardware devices. So yeah, this is the third part of our product suite. Generally, combining all these three gives a very good solution to our customers. Any questions so far? If you have any questions, feel free to chat.
Yeah, there's a question that came in over the chat. Where does your platform run? Is it on-premises or in the cloud?
Okay, great question. Yeah, we have both solutions, actually three solutions. We have a SaaS platform, so there's an API that you can, it's very easy to integrate with it, just an API that you can call and send us transaction details. But we also have a setup for VPC, so your own private cloud, we can set up our whole system there. Or we can also do an on-premise setup. So if you have your own hardware, your own servers that's located within your premises, we have a solution for that too. Actually, we have customers using all three solutions right now. Generally, customers who are having like low traffic, these are websites, e-commerce websites, and so on, they prefer going with the SaaS product. People who have very high transaction volumes, like financial institutions, they prefer going with a VPC or an on-premise setup.
Thanks, Ravi.
Lena, you can go to the next slide. Yeah, this about the scale and availability requirements. Yeah, so this is a very, very important area for us, especially on our engineering team. In terms of scale, Simility processes billions of transactions a day from customers across the globe. So we have two SaaS clusters, like I mentioned. So we have a cluster in the US and one in the EU, specifically for the EU data protection criteria. So all our EU customers just touch our EU cluster in our SaaS platform, but we also have, like I mentioned, VPC and on-premise setups for various customers. So our scale is in billions a day. Actually, in some cases, for our on-premise setups, these can be much, much higher. In terms of latency, since our customers are calling us within the transaction flow, basically their users would be waiting for the transaction to get completed. So we need to respond very, very quickly, and our response time needs to be 100 milliseconds. So this is including everything end to end, including network latency. So this is the call coming to us doing the feature generation, us computing executing all our machine learning models on top of it, calling third-party data, polling third-party data, all of these things, and then writing it back to our database. All of these should finish within 100 milliseconds. The final part about availability is, again, especially for our finance customers, availability needs to be very, very high. So we have a lot of moving parts. I'll show you in the next slide. So all of these moving parts should always be available. And I'll talk about why Redis is so mission critical for us because of this main criteria. So we generally try to keep 9995 availability for all our solutions. For our on-premise solutions, it is even higher. Next slide, please. This is a broad architecture diagram of our system. Again, these are just the major components of our system. I'll just broadly cover this. I know it might be a little confusing, so I'll take questions if you want any specific details about a certain component. But on the left-hand side is all our customer interfacing components. These are our API servers and our device recon web servers. Our UI runs on top of Node.js, and then there's a load balancer and all that kind of stuff. And in the middle are all our database components within our architecture. So we persist data right now on DataStax, which is basically Cassandra and Spark. We use OrientDB, which is a graph database for some metadata and graphing and so on. And then we use Kafka for certain parts of queuing, and then there is an offline data database called Druid, which is for querying, writing SQL-like queries on large data. But in center of it all, you can see that there's Redis. It kind of drives everything. On the right-hand side is all the components that process the data. So left-hand side are just the web servers. These are very simple servers that just take data and put it into a database. In most cases, this is Redis. And the right-hand side is where all the magic happens. So our AI engine, our pipeline workers, which compute the fraud score, our device recon workers that generate the device fingerprint, and then we have a third-party data hub that interacts with all the third-party APIs that we use to kind of augment our data set. These are like social details about users, or if the phone number, details about the network, the circle, and all those kind of things, geolocation, and so on. So all these components rely very, very heavily on Redis because of that latency issue that I mentioned. So you'll see that even though some components kind of write into Cassandra, all of them actually just read from Redis. So whatever data goes into Cassandra, about 95 to 98% of it goes into Redis also, because our reads need to be very, very fast. I'll just stop here. I won't go too much into detail. I think one other component is we use Kubernetes pretty heavily. This is like a container management system that's getting pretty popular nowadays. But yeah, if you have any questions, I can answer now or even at the end of the presentation, whatever you prefer.
Thanks, Ravi. I'll move on to sort of a little bit of introduction on why Redis and Redis Labs. I think you said a lot of it while you were covering your architecture diagram, which is really it is the latency requirement that's driving the need for Redis. We see this very frequently in our customer base, where the requirement is that for a standard end-to-end application response time is something like 100 milliseconds, just like you said, and in those 100 milliseconds, you have to bake in 15 milliseconds for the average round-trip latency, which leaves you 50 milliseconds for all your application processing, including database access, which means that your database needs to respond in sub-milliseconds. And this is typically where Redis comes in, which is also where Redis is used. So for those of you on the line who are not familiar with Redis, sort of the main differentiators for Redis are its performance. It can deliver millions of operations per second with sub-millisecond latencies using extremely few resources. So you'll hear a little bit from Ravi later on in the presentation about how many resources he's using to get hundreds and thousands of operations per second. And it's unquestionably one of the main reasons why Redis gets considered in the first place, because of its world-class performance. But that's not all. Redis comes with a range of data structures that enable a wide variety of use cases. And the data structures are very clever ways of implementing application functionality that would have taken tons of time to develop otherwise. And I'll do a little bit of an explanation of that in a second. The last but not the least reason Redis gets used is because of its extreme extensibility. Last year, the Redis community introduced Redis Modules, which is a way to package functionality, any database functionality, such as graph operations or search operations, into a module and implement it with the high performance and simplicity of Redis. Just a little bit of a deep dive on the performance. We've benchmarked Redis against other NoSQLs, and there are two things to remember. Not only do you get the highest throughput at the lowest latency with Redis, you also get it with the fewest number of resources needed. So on the right, you can see a graph. The graph is actually, these are benchmarks published in the Google blog by the different vendors themselves. And you can see that, data stacks with Cassandra needed about 300 Google Compute Engine servers to deliver 1 million writes per second, whereas Redis Labs needed only 2. The second piece about Redis, and definitely one of the more interesting things about Redis, are its data structures. Now, data structures include a wide variety, such as sets, sorted sets, lists, hashes, geospatial indexes, hyperlog log, and so on. And these really enable development of functionality in a very simple manner. As an example, you could use something like sorted sets to store time series data, and the range query in that case would be accelerated by a couple of orders of magnitude. Complex functionality such as get the email of the user with the highest bid and option becomes just a single command within Redis. And even more complex commands can be enabled by using Lua scripting, or in the new world of Redis, even modules. The key here is with these data structures come a set of commands which process the data right in memory where the data is stored, adding another performance boost to execution. So you get cleaner, more elegant code and faster execution times with Redis. Thirdly, modules can extend Redis in any direction. So there are add-ons that use Redis API for seamlessly adding use cases and data structures. They can be created by anyone. There are a number of Redis modules created by the community, by Redis Labs, and some of these make implementation of specialty database functionality very, very easy with the high performance of Redis. Redis Labs has over 60,000 customer accounts and over 6,800 enterprise customers in a wide variety of industries and verticals. And we power a range of solutions, one of which you're listening to today, fraud detection, but there's also a whole range of personalization, e-commerce, IoT, metering, social apps that Redis powers with Redis Labs. Now, our products are available both in on-premises. Our on-premises product used to be called Redis Labs Enterprise Cluster and will be called that for another couple of days. We're changing the name of that product to Redis Pack. And our cloud product is Redis Cloud. It is available in every cloud as well as in private clouds. The Redis Enterprise technology that powers both those clouds, both the cloud and the downloadable software product is really an enterprise layer added on top of open source Redis. So it has 100% support for open source Redis commands. But on top of open source Redis, we add a proxy, a cluster manager, and a REST API. The benefits of these additions is that you can scale Redis seamlessly without any downtime and with the same high performance that you normally enjoy. Clustering becomes very simple, and sort of the largest benefit of using Redis Enterprise is that high availability becomes a no-brainer. You get in-memory replication, persistence, replication across racks, zones, data centers, instant failure detection, and failover. And it's among the top reasons why our customers use Redis Enterprise. With Redis Enterprise, we also have we introduced a shared nothing cluster architecture for deploying Redis, which, as I mentioned before, is fully compatible with the open source. So there is little to no difference in your code. There are no changes that you have to make if you're already using open source Redis to upgrade to Enterprise Redis. Now, before I hand it over back to Ravi, let me see if there are any questions that have come in the chat. So I can see a question in the chat that's come in saying, what is this Redis E denote? And really, it's not yet obvious on the Redis Labs website, but it's a representation of the Redis Enterprise technology, Redis to the power of E, and it denotes the notion that with Enterprise Redis from Redis Labs, you you enhance the power of Redis because of the added benefits of seamless scaling, effortless high availability, and also the ability to reduce your cost significantly by extending it to flash memory. There's another question. Is Redis Labs configured for high availability at Simility? How does Simility manage the high availability architecture? And I will let Ravi answer this.
Yeah, we use the high availability setup for Redis. We use RLEC or Redis pack, that's called now. I can talk about it, and it's actually on the next slide, I think. I can cover it.
There's another question you might want to cover in your next slide, Ravi, which is, does Simility persist the Redis data, and what persistent techniques do you follow?
Yeah, great. Yeah, so perfect. So I'll cover it in the next slide. Cool. So yeah, we use Redis pack, previously called, I think, Redis Labs Enterprise cluster. Mainly, I mean, okay, before I go to that, I'll just mention what we use Redis pack for. So we use caching for our UI layer. We use it as a first in, first out queue for device recon. Actually, our device recon team and our API teams kind of compete on which queue, Kafka or the Redis queue, runs faster. The next one is we use it for pretty heavy statistical computations like hyperlog log. We have a bunch of custom Lua scripts that we execute for various other computations. We use it as our primary data source, data store for device recon, which was a little surprising for our entire team because Redis was previously seen as only like a caching solution, kind of replacing Memcache. But I think with all the new advances there, we are like super comfortable just using Redis as our primary data store, and then later on persist. Right now we are persisting in DataStax, but we'll see later on. Like, we use DataStax as a cold storage, but we'll probably look into something else in the future. And then obviously we also use it heavily for caching our metadata and our rules, our machine learning models, and so on. So in terms of our cluster, so we use a high availability RLEC setup, but the main thing is we only have like 3 nodes with very low, these are very low capacity VMs, only like 4 virtual CPUs and just a lot of RAM, but these are very low capacity ones, but we still manage to hit 100K to 500K operations per second very, very comfortably. This is in our SaaS setup. In our on-prem and VPC setups, we go much higher, like 1 million operations per second and so on. Again, not using very high capacity machines. Next slide, please. Yeah, the main benefits of Redis Labs, obviously, like when we started off, I was like the first employee of Simility, so it was just me and the 3 founders located in Palo Alto. I'm located in Hyderabad in India, and for us, we were just like a 3-member engineering team. We needed something. We were like huge fans of Redis. We used to work at Google before, and we used to use Memcache very heavily, but after coming out and seeing all the functionality Redis has, we became huge fans, but we were a little apprehensive about all the configurations, that conf file that Redis has. Setting it up for high availability clustering and so on was a little daunting for a 3-member team. So when we found out about Redis Labs, we kind of jumped we got a good discount from them, so there's no going back from there. So yeah, I mean the on-call support that we got, that we get even now from Redis Labs is pretty great. So we do like maintenance, scheduled maintenance with zero downtime. We had one or two like emergency issues, and then we got like support from them on Skype or so on within half an hour, within 10 minutes in one case. So it was pretty awesome. Like I said, even now our team is now 20 people on the engineering side, but still there's a huge reduction in operations overhead for us since we are continuing to use Redis Labs, especially because, like Lena mentioned, they provide a UI with a lot of dashboards, alerting systems, monitoring, and so on, which is like super helpful for us. And we didn't had to use any configuration at all. It was out of the box, so we didn't touch any configuration files when we set it up. Yeah, I mean that's the last point too. We chose Redis Pack because one is we deal with sensitive data since we work with financial institutions, so we cannot have our data cross our cluster, and we cannot give access to that data to anyone outside of like a strictly authorized personnel. So we had to use Redis Pack, and we chose Redis Pack for that, and we are pretty happy with it. Next slide, please. Yeah, perfect. So here I'll answer about the snapshots, about the persistence that I was asked about. So that's the first point. So I think one of the most important things is kind of decide what kind of persistence works for you, the AOF or the RDB. RDB is basically snapshots. AOF is you kind of keep persisting every command that Redis executes. So for large databases, RDB or snapshots is the best. It might be much faster to recover from. So if there's a downtime and so on, if you have a large Redis database, I would suggest using RDB. But if you get a lot of commits per second, for example, in our case, since these are all transactions, and you cannot afford to lose any of these transactions, you should also use AOF. We use AOF with 1 second fsync, plus we do periodic RDB snapshots, and we store it in S3 or like Google Cloud Storage. The second point is Redis has two very useful commands, monitor and slow log, but use them very judiciously. They cause a lot of latency. So try not to use them on your production setups, or use them only during like slow time, like on weekends or something like that. We realized this. I mean, we made this mistake once. But like Redis Labs gives you good graphs and monitoring, so you probably need not use it that frequently if you're using Redis Labs. Which comes to the next point, make full use of their alerting and dashboards. Our DevOps team, which is basically one person, is like a huge fan of this. And we continuously monitor those graphs. Use data eviction policy. Again, we made this mistake once. We had a huge customer suddenly pump in a lot of data, which caused our VM to crash. But again, decide on what eviction policy works best for you. We use something called as volatile LRU. And then finally use, obviously, I mean, nowadays no one uses anything else, but use SSDs for persistence, preferably NVMe if you have access to such disks for best input-output performance. yeah, so these are the best practices. Any questions on these?
Yeah, there are a few questions coming in. One was, how does Redis's performance compare to Kafka?
Oh, great. Yeah, Kafka, it was designed very specifically for queuing. So there is this, I would say as of now, uh, like as of today, like we just saw our Kafka queue input and output latency and Redis input and output latency, they are on par for us. But that's also that depends on the configuration that you have. We have a 5-node Kafka cluster. Again, it seemed a bit excessive for us, for me, for using Kafka, using 5 nodes for just Kafka, and its only use case is queuing. Whereas our Redis cluster, which is just 3 nodes, we use it for a ton of other things other than queuing, and still Redis is generally on par with Kafka. So only time we see Redis to be slightly slower is when there is load on our Redis cluster due to some other operations. So yeah, I don't have metrics offhand. If you want, I can ask my DevOps guy to pull those numbers and share it. But yeah, if you already have a Redis cluster, I'd say just use it for queuing. There's some very good libraries for setting up queues on Redis.
There's one more question that came in. Will the transactions be synced across Redis nodes apart from sync to disk? So in your setup, I'm guessing that's what it's about.
Yeah, they are. So our main, so there's this concept of databases. So we have 3 nodes, but we have 3 data. Let me quickly find out. Like we have, I think, 3 databases or something like that. So you can also choose like to have a master-slave setup for certain databases, and then if you have a master-slave setup, they'll be synced across both without needing to actually persist on disk.
There's one more question. Do you also use Redis Cloud on any of your cloud instances?
And yeah, like I mentioned, we couldn't use Redis Cloud, so I tested using I think Redis Labs had like a test account for Google Cloud customers. So we are hosted on Google Cloud for our SaaS setup. But our VPC, most of our VPC setups are on Amazon. But I think there was like we could test it out. So when I was testing Redis Labs, I just created an account and used Redis on Cloud. But I don't have big experience on that side because, like I said, we deal with sensitive data which we cannot host on like public cloud setups.
Cool, thank you. Should we move to the next slide?
Yeah.
All right, so I'll quickly summarize today's presentation. Basically, you heard from Ravi, who heads up fraud detection startup Simility's engineering department. And we talked about how modern fraud detection requires high scale and high availability plus an intelligent versatile data store, which is Redis, and how Simile achieves this very fast and intelligent fraud detection with Enterprise Redis. There are a few more questions that continue to come in. One is, does Redis Pack support cross data center replication? Yes, it does, and you can contact. I'll provide some contact information if you want to deep dive on that further. Our speaker today was Ravi, and you can follow him on Twitter, or you can contact him at Simility using contact@simility.com. And if you want to email me any additional questions, I'm also available on Twitter, and you can email me at expert@redislabs.com. With that, we will conclude today's presentation.
Hey, thank you, Lena, and thank you, Ravi. What a very, very compelling use case. And thank all of you for joining us today. An email will be sent to you with a link to the recording of today's broadcast. So go out and make it a good day, and bye for now.